wonderful, hey? All right, everybody, welcome back. It's really nice to have you all with us again this Thursday evening. Thanks, Nicole, for being my super amazing TA. You are wonderful, and I'm so grateful for your assistance every single time we meet. Today is the last lesson on analytical geometry, because next week, well, it's the last lesson, and then next week we start a shorter course on functions and inverses. So today I decided that I would do some exam type questions with you. I've just prepared 2 questions because I don't think we'll be able to get through more than that in an hour, but let's see how it goes. Both of these questions have been taken from NSC exams and end of year papers. So I think this is a good thing for us to work through together, because it gives you an idea of what it is that you're going to be facing at the end of the year. And I mean, ultimately, it also helps you for the exams that you're going to write now and for trials as well. Okay, so let's get started. Let's have a look at question 4, the first one. They're telling us here that we have a diagram with a circle centered at N. The coordinates are -1 and 3 at the center of the circle, and that the circle passes through point A down at the bottom and point C as well, which is up at the top. They also tell us that B, which is one of the vertices of the parallelogram, -1, 2, C, D, and E are joined to form parallelograms such that BE is parallel to the x-axis. CD is a tangent to the circle at C, and CD is 6 units long. Okay, so quite a lot of information that comes with this diagram. Let's go and have a look at the question. So the first thing that they want us to do in number 4.1 is they want us to write down the length of the radius. So when a question on matrix, it means that there's no calculating involved. It means that we literally are writing down the answer. It's only worth 1 mark. So now we go back and we look at the diagram and we say, well, where did they give us the radius of the circle? And this information has been given to us implicitly rather than explicitly. Anybody want to tell me what they think the radius is, or the length of the radius is, if you're looking at this diagram? Hopefully it's big enough. Ooh, made it a whole lot bigger. Anybody? Any ideas of where we should be looking at? Is it 3? No, Kumo, you're close, but not quite. Okay. You need to tell me what it is that you're looking at. What are you looking at, Kumo, when you said 3? Are you just looking at the y coordinate of N? What are you basing it? What are you basing?
Ma'am, I was looking at the y coordinate of N.
You were looking at the y coordinate of N. Okay.
Yes, ma'am.
But if you look at the y coordinate of N, that's great. That's a good place to look. What other y coordinate do you need to look at so that you can compare distance? If you want to know the length of the radius, then if we have the point in the center, the other point has to lie on the circle, okay, in order for us to measure the length of the radius. Okay, so we are supposed to be looking at, we're supposed to be looking at point A. Lovely. All right, so we need to look at point N and we need to look at point A. What do you notice, before we answer the question, what do you notice about A and N? What about them is the same? What do they have in common? Bochepo?
X coordinate.
They have the same x coordinate. What does that tell you? Yes, Neo, quite right. What does that tell you? They have the same x coordinate. What is the diagram telling you?
That they share the same x coordinate and they are aligned in a way.
I like what you're saying there. Absolutely. They are aligned. How, can you see,
Through the x values.
Okay, so in other words, what you're trying to say, without saying it, what you're trying to say is that they lie in the same vertical line.
Yeah.
Perfect. Okay, so they lie in the same vertical line. Very, very, very important for us. Okay, So now if they lie in the same vertical line and N is a point in the center and A is a point on the circumference, the distance between N and A must be the length of the radius. Does that make sense?
Yes,
So
ma'am.
does that make sense? Okay, so in other words, the length of the radius in this case is how many units? How many units, Matrix? Or Chepo?
Like I was going to say 4.
Yes, Neo also said 4. He put it in the chat. You're both correct. Absolutely. It's 4 units long. Okay, so from 3 to -1 is 4 units. Okay, absolutely. So there's the length of the radius. Okay, it's 4 units long. Good. Okay, next question. They want us to calculate the coordinates at C. The coordinates at C. Now remember, in analytical geometry, just like with Euclidean geometry, they are building a picture. So what you've already calculated, that's your starting point, and then you're going to use that information, okay, throughout the question. So why do you think they first asked us to calculate the length of the radius and then the coordinates of C? Because they want us to use that information. So what do you think the coordinates at C are, Matrix? So Neo says -1 and 7. Lovely, that is correct, Neo. They are -1 and 7. But you're the only person who said that, which worries me a little bit because it means, is everybody else just quiet because they understand, or are you quiet because you don't understand? You understand that. Okay. All right. Kulani don't understand. Okay. So Kulani, all right. We would not be able to determine the x coordinate at C if it didn't lie in the same vertical line. Okay. So there would be no way for us to be able to work that out. All right. It has to lie in the same vertical line. We can't just work out the coordinate at some random point. Okay. So it has to be in the same vertical line. All right. Then as far as, so that takes care of that value. Okay, as far as the 7 is concerned, what Neo has done here is he's taken this 3 and he's added 4 onto it, okay, in order to get up to the top over here where 7 is. Okay, so remember the length of the radius is 4 units. So if C is in the same vertical line as N and A, another 4 units up, and then we will have the coordinates at C. All right, so that's where it comes from. Okay, now that we have the coordinates at C, now we need to work out the coordinates at D. Let's see what's happening in the chat. Kashandra, you wouldn't need to use distance formula because distance formula is used when a line is diagonal. When a line is vertical or horizontal, there's no need to use, I mean, you can, but there's no need because the difference in a vertical line, the length of the vertical line is going to be the y at the top minus the y at the bottom. And with the horizontal line, the distance of the line is going to be the x to the right minus the x to the left. Also, you already knew that the radius was 4, so there was no need to use distance formula to work out something that you already knew. Okay, so x will be 5 because you told that it's CD, and 7. Yes, you're all perfectly correct. Okay, lovely. Okay, so you're getting that. So here the coordinates at D have to be 5 and 7. Okay, so D and C lie in the same horizontal line. That's why they share the same y coordinate, and absolutely add 6 units onto C to get to where D is 5 and 7. Lovely, Matrix. That's really nice. Well done. Oh, Kumo, I see you've got a question.
Ma'am, may you please explain how you got the x coordinates as 5 because it's still confusing me.
How you got the x coordinate at 5?
Yes, ma'am, as 5.
Oh, do you mean, hang on, let's just highlight this. Do you mean this 5 over here that I'm just highlighting, that one?
Yes, ma'am. Yes, ma'am.
Okay, so in other words, the way that they worked it out was like this. At C, the x coordinate is -1, okay? And when you go from C to D, the length of CD is 6 units. So you've literally said -1 plus 6, and that's where the 5 has come from.
Oh, I see. Thank you, ma'am.
Okay, does that make sense? Good. All
Yes, ma'am.
right, lovely, well done. Okay, now they want us to calculate the area of triangle BCD. I'm just having a look at these. Okay, so as far as marks are concerned, sorry, I'm jumping around. So 1 mark for that, 1 on the X, 1 on the Y, 1 on the X, 1 on the Y. That's how they would mark it. Now, the area of triangle BCD. The area of triangle BCD. So maybe what I should do, this is the great thing about working online. Hey, we can rub out everything that we've already got. Okay, so I'm just going to highlight this for you. BCD. So it would be that. All right, so BCD is a triangle and BCDE is a parallelogram. So if we know the length of this line over here, let me just highlight it in pink. This pink line, if we know the length of this pink line, then it means that we know the vertical height, the perpendicular height of triangle BCD. Does that make sense to you? The perpendicular height. Remember, we want to calculate the area of a triangle. I mean, unless we were using trig, we would have to say area of a triangle is equal to half base times perpendicular height, right? So we know that the length of line CD is 6. So that has to be the base in this case, because we don't know the length of BC and we certainly don't know the length of NB. Although I suppose we could work it out, but I mean, why go and calculate something when we've already got the information? So the vertical height of triangle BCD is the pink line that I have drawn, or the vertical pink line that I have drawn. Does that make sense to everybody? Matrix, is that okay? Is it making sense to you? Or do I need to explain that a little bit further? How do you feel? Yes? Okay. All right. Okay. All right. That's fine. Sorry, I didn't mean to hound you. I just wanted to make sure that everybody was on the right page. Okay. So half
Okay,
base
but
times...
sorry, Lee.
Yes.
But Shepherd needs help seeing the vertices there, the height.
Okay. All right. Okay. So just excuse me a second, guys, while I just help Watobe here. All right. So Watobe, when you have got a scalene triangle, okay, and I'm going to try and draw a scalene triangle over here. Ugh. Okay, so just ignore that bit for now, okay? If this line over here is the base, the perpendicular height has to be this pink side over here. Okay, so half base times height means that, like, if this line was, say, 3 units and this line was, say, 2 units, we would say that the area of the triangle is equal to half base times perpendicular height, and then get our answer. Okay, so that's what you need to see with this particular diagram as well, okay? here is the base. Right, so if we take a line at right angles to the base, to the top of the triangle, that's going to be the length of this line that I've colored in pink over here. Okay, so that's why it has to be, oopsie, I'm drawing all over the place. That's why that has to be the perpendicular height. Does that make more sense, Boitshepo and Morongoa?
Yes, ma'am.
Okay, so now we know. Yes, okay, so now we know that those two lines are parallel to one another. I'm just thinking now, how are we going to work out the perpendicular height? So it's a tangent to the circle over there. So we know that the coordinates over here, just let me write this down. So the coordinates over here are -1 and 7. So here, that's 7. That over there is 2. So the difference between 7 and 2, which is 5, is going to be the vertical height. Does that make sense to everybody? So here, the perpendicular height is 5. All right, so that's half of 6 times 5, so half of 30. So that would give us 15 square units in this case. Okay, yes, good job. Okay, nice one, guys, lovely. Okay, so we're working out the lengths of the lines using the coordinates. Okay, hopefully everybody's feeling good. Let's move on. And now they do something a little bit mean to us, but I suppose we have to expect this. The circle with center N, we remember we were talking about reflections the other day in the exam prep course. The circle centered N is reflected about the line y equals x. M is the new center of the circle which is formed. The two circles intersect at A and F. Okay, so we've got A, but they haven't given us F. All right, that's fine. First things first, do you guys know where the line y equals x lies on the Cartesian plane and what it looks like? What does the line y equals x look like?
Ma'am, it's a diagonal line.
It is a diagonal line. And does it have a positive or a negative gradient?
A positive gradient, ma'am.
It has a positive gradient, quite right. Okay, so it has a positive gradient. I'm trying to draw a line using, okay, I don't know why my thingy is not working, but all right, that's okay, doesn't matter. All right, so it's a diagonal line with a positive gradient. And it goes through the origin, doesn't it? That's the line y equals x. And what's special about the line y equals x is that if we reflect over it, whatever was the x coordinate is now the y coordinate, and whatever was the y coordinate is now the x coordinate. So I guess F has to be that point over there if that's A. Right, so we're going to have this new circle now. I wonder if it'll... I drew a circle so nicely the other day for the matrix. Why is it not working now? Anyway, I'm sorry, I don't want to waste time. Okay, so our new circle is somewhere over here. Does that make sense to you guys? Okay, so it's been reflected over the line y equals x, and that's where our new circle is lying. All right. They have told us the two circles intersect one another. So at F, which must be this point over here, remember E is the vertex of the parallelogram, and at A. All right, calculate, first things first, calculate the length of NM. Okay, so remember M is the new, was the center of the new circle. So first of all, in order to calculate the length of NM, now here, that would be a diagonal line. So we would need to use distance formula. We need the coordinates at M. So how are we going to work out the coordinates at M? How are we going to work out the coordinates at M? X equals 1. Okay, y1. y1. Remember, we reflected over the line y equals x. Can you see there? We reflected over the line y equals x. So when we reflect over the line y equals x, that's it. X is equal to 3. Yes, there we go. Okay, so this will be 3. And the y coordinate will be -1. Does that make sense to you guys?
Yes.
We have reflected point N essentially over the line y equals x. So what was x is now y, and what was y is now x. Is everybody happy with that?
Yes, ma'am. So, ma'am, can we say that M is the reflection, no, the inverse of N? Okay.
Not the inverse, a reflection of.
Or the reflection.
A reflection of, yes, yes. I understand why you want to say inverse, because you've reflected it over the line y equals x, but we use the word reflection in this case because we're reflecting a point. When we are talking about functions, then we would talk about an inverse function where we've reflected it over the line. Okay, but yeah, in this case, it would be a reflection. Okay, good, well done. Okay, so the distance of NM, now that we know the coordinates at M, this is easy for us. We're going to go and sub in. So that means our change in our x's is going to be -1 minus 3 squared, and our changes in our y is going to be 3 plus 1 squared, if I'm not mistaken, and that should give us root 32, if I'm correct. Just double check me that I am right. Sure. Okay, everybody happy with that? So yeah, in this particular case, the marks would be allocated. Sorry, I didn't tell you where the marks would be allocated here. So it has to be for the answer. It has to be for the perpendicular height, and I would say for subbing into the area formula. Here we have to have a mark for the coordinates at M, a mark for subbing into distance, and a mark for the answer. Okay. And now the last thing that they want us to do is calculate the midpoint of AF. Okay, so AF is an imaginary line that joins A to F, and they want us to calculate the midpoint. So if they want us to calculate the midpoint of a line, it means we need to know the coordinates at either end. So that means that we need to know the coordinates at F. Or is there another way that we could do this? How would we work out the coordinates at F? We don't really have enough information, do we? All right, well, we're going to have to think of something else then. What do you guys think we would have to do in this case? We don't know the coordinates at F. There isn't enough information for us to be able to work it out. So what else could we possibly do? Someone did put a hand up. Just Cassandra. Go for it, Cassandra. What do you think we would have to do here?
Since we have our O as our origin and we know our coordinates to be 0 and 0, we also know our A coordinates. Can't we use our reverse of midpoint theorem to calculate the coordinates?
I was also thinking that, but the thing is that if we want to use the midpoint formula and work backwards, then it means that we need to know the coordinates at F. And I don't think that we have enough information to be able to work that out based on what it is that they've given us.
Can't we use the coordinates of O?
Okay, but how do we know that that line goes through O?
Because our y is equal to, okay.
No, but what I'm saying
Ma'am?
is, how do we know that line? How do
Ma'am?
we know that line AF
Ma'am?
goes through O? I don't think we know that. Yes.
Ma'am, can't we calculate the gradients of AM and assume that the gradients of M and F will be equal to A and M, and then find the equation from there to find the coordinates of F?
I don't how. I'm not 100% sure how you. What? Just say that again. Sorry.
Ma'am, can you calculate the gradient of AM and then take the gradient of AM, assume that the gradient of AM is equal to the gradient of FM, and then from this use the gradient to find the equation?
No, you see, the reason why, I think you're right about us using gradient, but I think what you're saying here, that's not going to work, because if I join A to M, I can't say that the gradient of this line is going to be the same as the gradient of that line. Okay, because line
Okay, ma'am.
FM is much, much steeper. So there's got to be something else that I can do in this particular case. All right.
Okay, ma'am.
And I would say that, let's just see if there's somebody else with a suggestion here. I know what I'm going to suggest, but let's see what you guys say. Cassandra, what were you going to say?
Ma'am, can I ask?
Yeah, sure.
Ma'am, can we use can we say that the radius can we use the radius between can we say that the radius is equal to the distance between AM, and same applied with MF, it's gonna be the same equal distance, and then we can use our radius to solve the coordinates of F.
I don't think that the gradients of BD and AF look similar. BD, BD, and AF. They do look similar. Do you know what I think we're going to have to do here, based on yes, Neo, this is what I'm thinking. All right. This is my thoughts on this particular problem. Okay, is that I don't think that we've got enough information to be able to calculate the coordinates at F. Also, they've given us an important piece of information here. They've told us that it's reflected about the line y equals x. All right. So what that means is that the line y equals x must lie here on A through F. Okay, so in other words, so can you see where I drew the orange line? This is the line y equals x. And it lies on that piece of line between point A and point F. If we worked out the gradient of line NM, oh God, I'm drawing that so badly. These two would have to be perpendicular to one another, because it was a reflection over the line y equals x. All right, so it would have to be, the line from N to M has to be perpendicular to this one. So if we work out the gradient of NM, it means that we can work out the gradient of AF. Then what we can do is we can work out the equation of line AF, and then we can solve simultaneously, because we know that the midpoint, lies on line AF as well as the line y equals x as well. That's how I think we're going to have to do this. This is what I'm thinking. All right. So yeah, this was a really, really, really difficult, really difficult
Ma'am,
question.
can I just ask, ma'am? So you're saying that
sure.
we're finding the gradient of
MN.
MN, and then solve simultaneously between A and F.
And then what we're going to do from the gradient of mn, okay, so let's just work it out. Okay, so the gradient of mn is going to be 3 plus 1 over minus 1 minus 3. So what does that give us? That gives us 4 over negative 4, which gives us negative 1. That looks right. Okay, so now therefore the gradient of AF is going to be equal to 1, because those two lines have to be perpendicular to one another, all right, which means that we can now calculate the equation of line AF. We can do y equals mx plus c, which we're going to sub in point A, so minus 1 equals 1 times negative 1 plus c. So that means that c is going to be equal to add 1. Have I done something wrong here? That would have to be perpendicular. What, Shepo?
Ma'am, while we were going through the midpoint of AF, I was wondering about the radius when it comes to AN, and I was wondering about, due to the fact that they intersect one another, and
Yes.
also their reflection. Does that mean they have almost like the same radius or type of thing to be able to calculate F?
Just say that again, my goodie. Sorry, I've just realized the mistake I made. Sorry, just say that again. Sorry, Shepo. Sorry.
Ma'am, due to the fact that AF intersect with one another, and since when it comes to they reflect one another, doesn't that mean that they both have the same radius length, allowing us to be able to calculate F?
Well, what we could say here is that the distance from N to the midpoint and from the midpoint to M will be the same, as will the distance from A to the midpoint and then the midpoint to F. I've realized what I just worked out something that we actually didn't need. What we're going to do is this, okay? We've got the gradient of Mn. We can work out the equation of Mn, okay? So now working out the equation of Mn, this is the line y equals mx plus c, right? We know that its gradient is negative 1. Let's sub in a point that lies on the line, like n, for example. So 3 equals, the gradient is negative 1 when the x coordinate is negative 1 plus c. So this gives us 1 plus c equals 3. So c is equal to 2. So therefore the equation of Mn is the line y equals negative x plus 2. So now y equals negative x plus 2 and the line y equals x intersect over here at the midpoint. So here is the line y equals x, and we've just worked out the equation of line NM. Okay, this is the line y equals minus x plus 2. At this point, they would be equal to one another. So what we can do now is solve simultaneously. So in other words, we could take x and make it equal to negative x plus 2, take the x over, 2x equals 2, therefore x equals 1, which means that y has to be equal to 1. So the coordinates at the midpoint of AF, I suppose we better not call it M because we've already got an M. So the coordinates at the midpoint are going to be 1 and 1. Does that make sense to everybody? That's the only way I think I can think of to do this. Are you guys okay? That was a difficult question.
Ma'am,
Yes.
so would that mean that if we had to use the midpoint formula using the coordinates of n and m, would we get the same answer?
That's a good question. Let's try that.
Yes, ma'am, it seems like we get the same answer.
Okay, let's try that. Okay, so if we said, I'm just going to have to rub something out here. Okay, so if we've got minus 1 plus 3 over 2. And then here we've got 3 plus negative 1 over 2, minus 1 plus 3. Okay, so that's going to give us negative 2 over 2. This is going to give us 2 over 2. No, why are we not getting the same? No, we are. That's positive. That's 1 and 1. Yes, absolutely. That would have been so much easier, hey? But then are we making an assumption? No, we're not making an assumption because the line, it's been reflected, absolutely. So in other words, that has to be equal to that. That would have been so much easier, wouldn't it?
Yes, ma'am.
Oh, shame, Cassandra. Oh, sorry, Cassandra. I'm sorry I bamboozled you there a little bit. Sorry, maybe this question was actually a lot easier than what we thought. Cassandra, do you want me to go through it again?
Yes, ma'am.
Okay, all right. So what I was trying to say here in question 4.3.2 was as follows. Okay, so we have our circle that goes through A and it goes through another point over here, which we call F, all right? They want us to work out the coordinates at the midpoint of line AF. So it's like we've joined A and F with a straight line, and we want to work out what the coordinates at the midpoint are going to be, okay? What we need to remember is that circles and lines are symmetrical, right? So if I am drawing a line from A to F, okay, it's going to be halfway in terms of length and in width from A to F, all right? What I was saying is that if we connect M and N with a straight line, okay, because this point has been reflected over the line y equals x, the line AF, the line y equals x, has to be perpendicular to it. Okay, so those two have to meet one another at 90 degrees. So what we can do is we can use the fact that they intersect one another at that point to find the coordinates at the point of intersection. Okay, so in other words, this midpoint. So what Karisile was saying is that this bit over here and that bit over there has to be midway, doesn't it? Right. So another way for us to be able to do this would be to use midpoint formula, which was much, much easier. And then that's what I had done up here in green, where I worked out the midpoint of line, basically the midpoint of line NM, which has the coordinates 1 and 1. It's the same coordinates. And we would get the same answer as if we solved simultaneously, right? So AF lies on the line y equals x. We're going to work out the equation of line NM, and then we're going to do a simultaneous solution. So working out the gradient of NM, that's what's given us -1. Here we worked out the equation of line MN. It is the line y equals minus x plus 2, and then we are saying that these two lines cross one another at 90 degrees. I suppose the fact that they cross one another at 90 degrees doesn't matter. The point is that at this midpoint they are equal to one another, which is why I have taken this x and that y and replaced it with x. I've subbed in from here like that. That's what I was doing over there on the left hand side, and then just solved for the x coordinate and then for the y coordinate. Okay.
Thank you, ma'am.
Okay. Sure, nice question. All right, are we ready to move on?
Yes.
Okay. Let's go and have a look at the next one. Okay, so here, also question 4, also from a year-end paper. two circles now. So in the diagram, a circle having center M touches the x-axis at A and the y-axis at B. A smaller circle centered at N with coordinates -1/2 and 3/2 passes through M and cuts the larger circle at B and C. B and C is the diameter of the smaller circle. Okay, and a tangent drawn to the smaller circle at C cuts the x-axis at D. All right, so the first thing that they want us to do is they want us to determine the equation of the circle centered at M in the form x minus a squared plus y minus b squared equals r squared. So what do you guys think we would need to do in this case? What do you think we would do? This is easy, but it's also difficult, this question. Remember, M is the center of the circle, right? So the distance that M is from the y-axis would be the same as the x-coordinate at A, wouldn't it? And the distance that M is from the x-axis would be the y-coordinate at B. So that means that the coordinates at M have to be -1 and 1. So therefore, it has to be the line the circle x plus 1 squared plus y minus 1 squared equals, and now we've got to work out the length of the radius, and that would obviously also be 1 in this case. Well, obvious to me, I don't know if it's obvious to anybody else, but there we go. Are we happy with that? Okay, question 4.2. Okie dokes. Question 4.2. Calculate the coordinates of C. Let's just see how many marks this is out of. Okay, only out of 2 marks. All right, well, that's also not a particularly difficult question. They've told us that N is the center of the circle and B is a point on the circumference. So now we're going to have to work backwards using midpoint formula. So that means that the x at C plus 0/2 is equal to -1/2. And the y at C plus 1/2 is equal to 3/2. Is everybody okay with that? So that means that the x at C has to be -2 and the y at C has to be 2. So I say -2 and 2. I hope I'm correct. I'm wrong. I'm just checking myself here. 0 plus -1/2. Yeah, I was also just looking at it near. I also thought I'd made a mistake here. It should be -1. Sorry, my mistake. Quite right. Sorry, silly little calculation error. All right, there we go. All right, so the coordinates at C are -1 and 2. Perfect. Now we need to show that the equation, yeah, thanks Neo for spotting that. Show that the equation of tangent CD is the line y minus x equals 3. So what's really important with questions like this is that we are not allowed to use any of the information that they have given us in order to be able to prove that it's true. So we basically have to calculate the tangent of line CD and pretend that we don't know what it is, okay? So let's just think about the information that we've got. First of all, we know the coordinates at C. So they are -1 and 2, right? So if we want to work out the gradient of line CD, how do you think we would do that, Matrix? Given that CD is a tangent.
Don't we first have to work out the gradient of CD?
Just say that again, I couldn't hear you.
Don't we first have to work out the gradient of CD?
Yes, we first have to work out the gradient of CB, and then the gradient of CB times the gradient of CD will give us -1. Okay, absolutely, quite right. All right, so we can work out the gradient. Let's just get rid of me over here. We can work out the gradient of CB. Okay, so that gives us 2 minus 1 over -1 minus 0. So that gives us 2 minus 1 is 1, so that would be -1. Do you guys agree? Okay, therefore, the gradient of CD is going to be equal to 1, and then line CD goes through point C. So subbing into y equals mx plus c, 2 equals 1 times -1 plus c. So 2 equals -1 plus c, add 1, so c is equal to 3. All right, so therefore, y equals 1x plus 3, which means taking the x over to the other side, we would end up with exactly what they gave us. Does that make sense to everyone?
Ma'am, when
Yes.
calculating the gradients between 2 points, ma'am, how do we
Yes.
know which points will have the y1, y2, x1, x2, ma'am? Because sometimes, like for instance, ma'am, I got my gradient as a -1/2, and that's because I used the coordinate of B as my y2 and not y1. So I said,
Okay.
so ma'am, I said instead of saying 2 minus 1, I said 1 minus 2. So that's what confuses me, ma'am. Like, when do you know what is your y2 coordinate?
No problem. Okay, so if you have got the coordinate at B and you've got the coordinate at C, all right, it doesn't matter which one you make y1 or y2. What's important is that when you are working with gradient formula, if you start here with that particular y coordinate at the top, you have to start with its corresponding x down at the bottom. Okay, so in other words, you can work out gradient in 2 ways. If I start with 2 at the top, I have to say 2 minus 1, that's that one there, the change in y, over -1 minus 0. Or if I start with this one over here, I can say that gradient is equal to 1 minus 2, and then I've got to go back and I've got to start here with that 0 over there. So 1 minus 2 over 0 plus 1. Okay, does that make sense to you? And then you'll see you end up with the same answer.
Thank you, ma'am. I see my mistake, ma'am.
Okay, Kumo, no problem. All right. Get rid of all of that. Where were we? Okay, so we've done this one. We've done 4.1, we've done 4.2, we've just done 4.3. Lovely. Okay, so now in question 4.4, questions start to get a little bit more difficult now. They've asked us to determine the values of t for which the line y equals x plus t will not touch or cut the smaller circle. Okay, so in the situation over here, when they're talking about the line y equals x plus t, all right? The T represents the y-intercept of this line, all right? So we know from what we've been given that if we extend line CD so that it goes all the way to the y-axis, that point over there, that's going to be 3, right? Now, can you imagine if I could draw a line that was parallel to line DC, all right? So that it went through the other side of the circle, was also a tangent at point B, like that. So these two lines are parallel to one another, all right? So here, the value of T, or the y-intercept, is equal to 1. So if we want a value of T so that this diagonal line does not touch or cut the smaller circle, then it means that T either has to be bigger than 3 or T has to be smaller than 1. Does that make sense to everybody? So that it doesn't touch or cut through the smaller circle.
Ma'am, can you please explain again?
Sure. Okay. So when they are talking about the line y equals x plus t, it's parallel to DC because it has the same gradient. Okay, so the gradient of this line over here, of line CD, is 1. Sorry, I put is 1. So what I'm saying is that this line, if we draw another line over here that's parallel, okay, so these lines are parallel to one another, they have the same gradient, right? When this goes through the y-axis over here, well, the y-axis is equal to 1 at that particular point. All right, so the values of T, that these two straight lines will not touch the intercircle, has to be when T is bigger than 3, because then DC would have moved up. And it has to be smaller than 1 because the line through B would have had to move down. Does that make sense to everyone?
Yes, ma'am.
Okay. All right, question 4.4. Now 4.5. Okay, so here, the smaller circle centered at N is transformed such that point C is translated along the tangent to D. Calculate the coordinates of E, the new center of the smaller circle. Okay, so what are they trying to tell us in this case? All right, they are telling us that this smaller circle is going to be moved. All right, so it was originally centered here at N, and now it's being translated along the tangent. So in other words, it's moving along that line, okay, down to E, which is the new center of the smaller circle. All right. Okay, so in other words, C is translated along the tangent to D. So in other words, what they are saying is that where C is now, C now ends up at D. Does that make sense to everybody?
Yes, ma'am.
Okay, so we're gonna just literally slide down the line like this. Okay, so we're moving from point C down to point B. Oh, sorry, you were asking how we get our marks. I would say full marks for answer only, Kulani, for question 4.4. I don't think there's, you would definitely get full marks for that, for answer only. Okay, so I guess one way to look at what's going on here is that we're kind of drawing a rectangle in a way. I don't know if you guys can visualize this, but how C moves down this tangent to D is the similar way that point N will move down a parallel line to another point over here. So we're drawing Does that make sense to you? Okay, so that has to be perpendicular. So that means that has to be perpendicular, which means that has to be perpendicular. So it has to be a rectangle. All right. And in other words, where we are going from C down to D is the same way that we would go from N down to E over here, which is going to be our new coordinates. Okay. Because we are, do we know the coordinates at D? No, we know the coordinates at C though.
Ma'am, can't we find our coordinates of D first before doing all of this?
Absolutely. Because I was just thinking there's a couple of ways in which we could do this, because this DENC is a rectangle. So we could probably use midpoint formula as well if we wanted, because the midpoint of DN would be the same as the midpoint of CE because it's a rectangle. Or the other way that we could do this question if we wanted to is to use translation. And I quite like using translation because you get to the answer quite quickly. All right, so in other words, what we're considering here is that as we go from C to D, so however many left and down from C to D is the same that we would go from N to E. All right, so yes, we absolutely can work out the x coordinate at D because we know the equation of line CD. So we know it's the line y equals x plus 3. To work out the x coordinate at D, we would have to let y be equal to 0. So that means that x would be equal to -3. All right, so at D, the coordinates are -3 and 0. So now if we consider a translation, so C maps on to D, we've gone from -1 to -3, so we've subtracted 2 from x, and we've gone from 2 to 0, so we've taken 2 away from y. Therefore, N maps onto E by the same translation. So we've got -1/2, which is the x coordinate at N. From that, we need to subtract 2. The y coordinate at N is 3/2. From that, we need to subtract 2, and that will give us the coordinates at E. Okay, so at E, the new x coordinate will be -5/2, and the new y coordinate would be -1/2. Does that make sense to everybody?
Yes, ma'am.
Is everybody happy with that? Okay. So yeah, I think translations, as I say, you could also use midpoint if you wanted, because the midpoint of DN and the midpoint of CE would be the same one. Either way, we would need to work out the coordinates at D to be able to do that particular question. So there must be a mark for calculating the coordinates at D and then using a translation and then working out the coordinates at E. How much is that out of? Yeah, 3 sounds right. Okay, so yeah, yes.
So all in all, are you saying that in order to find our coordinates for D, use your x-intercept, which is y is equals to 0?
So yes, correct, because D is the y-intercept of line CD, yes.
Okay.
Okay. All right, Nicole, I'm not sure what I should do because I wanted to finish question 4.6, but our time is also up.
It's up to you, Lee. You can go ahead and
Can I finish it? Do you mind?
No, not at all.
All right, okay. Cool. All right, so guys, this is also going to be a difficult question for us to do. Let's just bite the bullet and get it done if that's all right with everybody. If you do need to go, you're more than welcome to. That's not a problem. But I did just want to finish this question with you so that we are all done. All right, so now they say to us, it is given that the area of quadrilateral let's get rid of this pink rectangle so that we can see what's going on here again. Okay, so the area of quadrilateral OBCD, so that's this. I'm just going to highlight it in purple. OBCD is 2a squared units, and a is positive. Show that a is equal to √7/2. All right, so now the area of a quadrilateral, this particular quadrilateral, remember we know that A and C are in the same vertical line, right? So what that means is we could split the quadrilateral into two different shapes. Here on the left-hand side, we've got DCA, which is a right-angled triangle. And then here on the right, we've got AOBC, which is a trapezium, because obviously these two lines over here have to be parallel, okay? So what we could do is we could say the area of trapezium, and if you do know the formulae to these, it does help, obviously. So the area of the trapezium is half the sum of the parallel sides multiplied by the perpendicular height. That is something that you should have encountered before, but yeah, if not, then it is something worth studying. Okay, so the area of the trapezium is going to be half the sum of the parallel sides. So that means that the one parallel side is 1 unit long, that's OB. The other parallel side is 2 units long, that's AC, multiplied by the perpendicular height. And the perpendicular height in this case would also be 1 unit, wouldn't it? Because the perpendicular height is the distance between O and A, so that would be 1. So this gives us 1/2 times 3, so that gives us 3/2 square units as the area of the trapezium. Now we're going to work out the area of the triangle. Okay, so the area of triangle DAC, again, it would be half base times height. So if we said that the height was AC, the length of that line would be 2, wouldn't it? And from A to D, D was -3, so that would also be 2 units long. So that would be 2 square units. Everybody happy with that? And now what we can do is we can add the areas together. Okay, so the area of quadrilateral OBCD is going to be 3/2 plus 2, which gives us 3.5 or 7/2 square units. And now that we know that the area of the quadrilateral is equal to 2a squared, it means we can say, well, 2a squared is equal to the area. Divide both sides by 2, that gives us a squared is 7/4. And now when we take the square root, remember they told us that a had to be positive, and that would give us √7/2. That was a bit easier. What do you think? Does that make sense, everyone? Okay, all right, I'm glad. I can imagine you must feel like your brains are a little bit blown tonight. I mean, we've done 2, but look, let's be fair, all right? If we have a look at all the questions that we've covered tonight, okay, Matrix, just 2 more seconds, think about it. Out of the 15 marks from the first question forward, it was only the midpoint of AF that was difficult. Everything else was fairly straightforward, wasn't it? So really, it was 11 marks are straightforward, and then it was those 4 marks that were difficult. Then when it comes to this particular question over here, Okay, so question 4.6, I didn't think question 4.6 was too bad. I didn't think 4.5 was too bad. Maybe 4.4 was a little bit difficult, but the other questions weren't so bad. Do you agree? So
You're
you know,
right.
don't- yeah,
I
so
feel
don't,
like it's the last of every set that's a bit of the trick one.
yeah, absolutely, absolutely. And the rest of the stuff is meant to be accessible. And you know what? Even if you left out this question 5 over here and that question 4 over there and did everything else, you would still end up with, let's just count the marks, you would end up with, because it would be 11 marks here, 11 and 15. So you'd still end up with 26 out of 35. Even if you left this difficult stuff out. So 26 out of 35. If you left out those difficult. Am I right, Nicole?
74%. That's
74%. Okay, so don't let those difficult questions intimidate you. Okay. No, it wasn't easy. I mean, even I was puzzling a little bit what to do with AF for a little bit there until I figured it out. But absolutely, you know, you've just got, that's why we've got to do these exam questions, so that you guys see all these different possibilities and the way that they do things, etc., etc. Okay, so just hang in there and keep practicing. All right, and of course keep coming to Watobe so that we can help you. All right, everybody, I'm sorry I went over. Thank you for being so patient. We will see you next week. I hope you all have a lovely weekend. And don't forget about the quiz. Yes.
Yeah, quiz today.
Yes.
Have a
Quiz
chance
today.
for that.
Okay, bye everybody. Bye, Cassandra. Pleasure, Kanisile. Pleasure, Cassandra.
Ma'am,
Hmm?
I want to say thank you for the lessons.
Oh, it's a pleasure, Kanisile. I hope that you've enjoyed them and that you found them useful.
And I have found them useful because we started writing our exams like this week Monday, and I was writing maths on Wednesday, and I actually enjoyed the math paper like for the first time in my high school career.
Oh wow, that's amazing, Kanisile. I'm so glad to hear that. That's wonderful. So you say your paper went well?
Yes, ma'am.
Oh,
We're
that's
aiming
brilliant.
for
And
that distinction.
oh, I'm so glad to hear that. Well, when you get your results, you must please share them with us so that we can see how it's helped you. And I really hope that it has. Okay, that's great. I'm so glad.
Yeah, thank you, ma'am. Thank you
It's
very
a
much.
pleasure. It's an absolute pleasure, Kanisile. It really is. You're a pleasure to teach. Thank you for always participating and always having such positive things to say. Okay.
Yes, ma'am. Thank you.
Okay, take care, Kanisile, and have a lovely weekend.
You too, ma'am. So
Thank you, my darling. Okay. Okay, me too. Okay. Bye.